Hi, welcome to lesson 9 of the CSEC chemistry at Edu Solutions Institute. So today's lesson, we'll be continuing on last week's lesson where we learned on the basis of creating chemical compounds. So today we'll be exploring that option a little bit more. So in today's lesson, we're going to look at creating chemical compounds. We're going to name in binary compounds that contains metals and nonmetals, that contains both nonmetals as well as containing polyatomic ions. Now let's look at metal and nonmetal. So we know that metals would be elements that are in group 1, 2, 3, right, or group 1, 2, and 13. And then the nonmetals are from group 15 to group 17 for their reactivity aspect. So if we take this example, metal of sodium going to react with a nonmetal of chlorine, then we get the compound called sodium chloride. Now, how do we get sodium chloride? Because if we look at this table here, sodium will have a +1 because in group 1, it's going to lose 1 electron. So therefore, it's going to lose 1 electron, and that chlorine on the right-hand side, which is an anion because it's going to gain 1 electron. So hence we get 1 sodium is going to combine with 1 chlorine. So therefore, we get a formula that says NaCl. And then the name of that is that we change the non-metal part to an IDE at the end. So therefore, it's not chlorine, it would be chloride. So we get sodium chloride, right? Just as if we were doing potassium and fluorine, then it would be potassium fluoride because the INE changes to the IDE of the nonmetal, right? So if we look at aluminum and chlorine now, then we see that aluminum is 3+ because it's going to give 3 electrons because it's in group 13. And chlorine is in group 17, so it's going to get 1. So if aluminum has 3 to give and chlorine only needs 1, then that means we're going to need 3 chlorine to the 1 aluminum. So therefore, in this case, we have the formula that says that it is AlCl3. Right? And that's what we see here. The cation, which is the metal part, comes first. The anion, which is a non-metal part, comes second. So this formula would be aluminum metal, and then the chlorine will become chloride. So we get aluminum chloride. Right? These are other examples. We could have potassium chloride. We could have magnesium bromide and calcium oxide. So all these includes a metal first and then a non-metal, changing the N to IDE. Alright, so these are some examples you can try and you can put your answer here, right? It shows that SrBr2 is strontium for Sr and Br is bromine, and we change the INE to IDE, so we get bromide. Alright, so these includes metals in our transitional section of the periodic table. And what these means is that we can change how much they can give. So it's the same process, it's just that they're more specific. So we can have iron 3 or iron 2. So depending on how much it has to give based on the question, then you know how much it's going to offer to the non-metal. So in this case, iron 3 bromide is giving 3 to the bromine, so therefore it's FeBr3. But iron 2 bromide is FeBr2 because it's giving 2 to the bromine. Notice in the name, we specify which one it is. So we put it in bracket after the iron that it is 3 or it is 2. Right? And these are some of the popular non-metal or metallic transitional metals that we use at this level, which shows that some of them have different ions amount. So for iron Fe, it could be 3+ or it could be 2+. For copper, it could be 2+ or it could be just 1+. For Pb could be 4 plus or it could be 2 plus, and the list can continue as it is. So it is specific based on which ion we're focusing on. So here we have another example where we can use iron with oxygen, and this iron is iron 3 plus. So we know that iron 3 plus means it's going to give 3. Oxygen needs 2 because it's in group 60. So therefore, all we do is to switch over the 3 to the oxygen and the 2 to the iron. So we get Fe2O3. And the complete name of this would be iron 3 oxide. We add the 3 because it's specifying that it is a 3 plus ion that we use for iron rather than the 2 plus ion. Alright, here are some other examples. Copper bromide. Right, now this one we know that copper is given 1, so that's why it's copper 1 bromide, because bromine only needs 1. Right, FeS, S needs 2, so therefore if it's just FeS, then it's 2 iron 2 sulfide. And then we have PbO2, which means that the Pb has to be 4 because oxygen needs 2. So if it's PbO2, then it was 4 Pb to 2 oxygen, and we reduce it, so we get 1 Pb and 2 oxygen remaining after we switch around those ions. Right? The name of this compound, CrO2. So therefore, oxygen need 2. Right? So therefore, when it switches with chromium, then it's Cr2O. And in order for you to get 2 for oxygen, that means the 4 would have been switched over. So therefore, when you reduce the 2 and the 4, you get that the chromium is 1 and the oxygen now becomes 2. So we know that it's chromium 4 oxide for this specific formula. Alright. Now, in addition to using the different ions amount, we could use prefixes to identify how much of each atom is there. So example like carbon dioxide. So the di before the oxide represent that it is 2 oxygen that's in this compound, right? Or the carbon monoxide, the mon represents that we only use 1 oxygen in this compound, right? And then for phosphorus trichloride, also that would mean we have 3 chloride ions that we use in this formula. And carbon tetrachloride, we have 4 chloride that was used in this formula, and the list goes on. So we can use prefixes to help us to distinguish how much of each metal or non-metal we use in our specific formula. Use 2 non-metals, right? So in 2 non-metals, we will use a combination of non-metal with a non-metal. And based on our previous lesson of bonding, we know that this will be a covalent bonding. And in this case, all we're doing is just putting both together in the same manner, but in naming, the name becomes different. So the one that comes first, right? So example, if we have silicon and carbon, then we get carbon silicate. So finally, for the 2 nonmetals, like CO2, it's carbon dioxide, which shows that we use 2 nonmetals, right, to one, which we know from previous lesson would be due to covalent bonding, right? The di shows that it's 2 oxygen, right? Then we have SF6, which is sulfur hexafluoride, which tells us that we have 6 fluorine. Right? So we can use nonmetals, metals, or 2 nonmetals with creating any compound that we hope to accomplish under the conditions that's needed. So that's it for today's lesson. Hope you understand, and I'll see you next week.